Okay, so this is a pretty busy slide and lots of important things about the Earth-Moon system on it. As you guys know, okay, the Moon orbits or revolves about the Earth, and actually, it's all about counterclockwise. So we're going to see it's kind of a counterclockwise orbit. The thing about the moon is like the planets in that it doesn't create its own energy. So the only reason we see the moon is because the sun sends it light, or sun sends light in all directions, and the moon is in the direction of one of the directions of the sun. And so actually half of the moon is lit all the time, and the reason we see the moon is because light from the sun reflects off of it. It can be very bright though, can't it? It's what we say, it's got a high albedo, it's very reflective, just because of, well, in part because it's so close to us, because it really does kind of suck up a lot of the sunlight that hits it. The thing about it, we're going to talk about lunar phases. If you're already familiar with a full moon, that's one lunar phase. When you can't see the moon at all, actually it's between the Earth and the sun, sort of, and we call that a new moon. That's another phase. So the different phases we see of the moon occurs because of its orbit about the Earth. And I'll try to kind of convince you on that. But rest assured that half of the moon is always lit up. One hemisphere or half of the moon is always lit up. And we see it at these different phases, like a quarter is another phase. A full is one phase. We see it the different amounts of the disk lit up because of we are privy to just that portion at times. So those are things to kind of remember. Let's see, one other thing before we get started. When we look up at the moon and it's not a full moon, there's going to be what we call a terminator. And the terminator is, I'll kind of draw a little picture here. I'll go ahead and draw a picture of a crescent. And so as I've drawn it, it's funny because we all kind of infer that this is the lit side and this is dark, okay? But as I've drawn this, the line, the boundary between the lit and the dark side is called the terminator. And actually, that is if you're viewing the moon with a telescope, that is kind of a sweet spot to look, because you see kind of if there's any sort of craters or mountains there on the terminator. It's cool to you get more of a sense of them, as part of them are shadowed and part of them are lit up. That's really cool. So let's look at the different phases the moon can be in. Now I like this. It's kind of a busy sort of figure, so we'll kind of hone in. I think your author's done a great job just to kind of orient yourself in this figure. This gal is the Earth. Okay, she is the Earth. And we see the moon orbiting the Earth in, of course, a counterclockwise motion. That's the orbits. And she's holding up the moon at different positions. So up here, the shaft, this is the sun. The sun is coming in and hitting the moon. So I think we'll start out with this location right here. When the moon is there, notice that the lit part of the moon is facing away from the Earth. So all we can see is this dark side of the moon. I'm sorry, it's not the dark. Well, all we can see is this non-illuminated side hemisphere of the moon. So actually, this is what we call, and I'll kind of zoom out. Okay, this is what we call a new moon. So a new moon is actually, the sun's up here. Oops, the sun's up here. A new moon is between the Earth and the sun. Okay, that's a new moon. And so it's going to rise with the sun. So here's the deal, though. Over the course of less than a week, maybe 4 days or so, okay, the moon is going to go ahead and get farther and farther from the sun's disk in our skies. So if you kind of draw your attention to this location right here, that corresponds to, this is what you'd see up in the sky. I think this is quite clever. This is what you'd see up in the sky. And we call that, since it's getting larger, we call that a waxing. And since it's a sliver, okay, anytime you see the word crescent, think sliver. Since it's less than a quarter, we call it a crescent. So this is a waxing crescent. And notice in the daytime sky, we're going to see more and more space between the sun's disk and the disk of the moon. So if I go about a week from new moon, okay, we're going to get to what's called first quarter. Okay, so here, in this position right here, this is what you're going to see up in the sky. It's what we call the first quarter, and I don't know if you can kind of tell it from this figure, but first quarter then is at a 90-degree angle. The moon is at a 90-degree angle relative to the sun with the earth at the vertex. Okay, so that is first quarter, and it takes about 1 week to go from new moon to first quarter. Well, the moon's not going to sit still. It can't. Okay, so it's going to continue on its way, orbiting the earth. And the next phase we would call, and I think of it as kind of a more of a minor phase, but I'll zoom in so you can see it better, is this right over here. So after first quarter, notice that it keeps getting bigger, so we continue with the waxing term because it's getting bigger, but it is larger than a quarter, so we call it a gibbous. So it's a waxing gibbous. Then about 1 week after first quarter, so this is actually position 3, okay? If new moon is position 1, first quarter is position 2, full moon would be position 3 is the way I think of it. Okay, now notice at full moon what we have, let's see if this will work for you. We actually have, in a straight line, we have the earth, the moon, and the sun in a straight line. So another way to think of it is as the sun is setting, the moon will be rising, and as the moon sets, the sun will be rising. It's kind of a fun configuration. So, well, the moon can't sit still there, so it needs to continue its orbit about the earth. And the next phase, kind of maybe more of a minor phase again, we get is what we call a waxing now. It's waxing because it's getting smaller. I tell students kind of if you go from whatever on the right is going to continue from the right to the left. So it's dark over here, it's going to continue getting dark. A little bit ago with the waxing, it was light over there, it's going to continue to get light. Okay, so this is a waning gibbous. Gibbous because it's larger than a quarter. Okay, and that corresponds to this position right here. I don't know if you can see this position right here again. Let me kind of slide down here. Over there, it would be the fourth of 4 positions, major positions, as the moon orbits the earth. And this again, it's at a right angle to the sun with the earth at the vertex. Okay, and this is the last or the third quarter. So then we come back, getting close to the moon coming back again in between the earth and the sun. Okay, so here we have one more position over here between third quarter and new moon. It's not a specific position, but it's kind of on more of a continuum. Okay, we have what we call, since it's getting smaller, waning, and since it's smaller than a quarter, crescent. So a waning crescent right there. Okay, so I think they did a good job. So again, I would call this first position, second major position. Third major position was the full moon. Fourth major position would be the third or last quarter. So I'm showing you this slide because I've got it in my PowerPoint slides. This is actually, I think you have access to these if you have Mastering Astronomy. And here's my slide to go ahead and kind of show you all of the phases of the moon. Okay, so notice we go from new to it's getting larger, new all the way ultimately to full. So we call these processes waxing. Okay, we use the term crescent if it's less than a quarter, and gibbous if it's larger than a quarter. And then after that, after full, of course, we have a waning process. And it'll be a waning gibbous first, and then a waning crescent, which between is a last quarter. So, very good. So, another cool thing about the Earth-Moon system is the fact that the distance at which the Moon is in orbit about the Earth changes. It varies. It's an ellipse more than a circle. Okay, so the two major spots are called perigee and apogee. Okay, perigee, I'll just go ahead and write it here, is when the when the Moon is closest to the Earth, and apogee is when the Moon is farthest. Farthest. Get the idea. Okay, so here's the deal then. And oh, by the way, I didn't emphasize this, but hopefully you guys see the cute little blue dot is supposed to be the Moon, and that little dot up there is the Earth. Excuse me. Oh, I can't believe I did that. The little pale blue dot is the Earth. My goodness. Here's the Earth, and here is the Moon orbiting the Earth. So, if you've ever heard of supermoon, okay, so if you have a full moon and the Moon is at its closest point, okay, perigee, okay, that is a super full moon, otherwise called just simply a supermoon. Okay, alrighty, and actually we have a supermoon coming up in a few weeks this fall. I want to end with, maybe you've heard people talk about the near side or the far side of the Moon. Kind of lets you fill in the blank if you need to. The near side and the far side of the Moon. If I'm doing my lectures and I'm not giving you enough time to fill in the missing word, let me know, and I'll try to adjust there. But I really like, again, this figure, but we need to kind of switch what this gal is doing, because here we see the Earth in the middle there, okay, and she now is not the Earth, she is the Moon. And we talked about the fact that the Moon is going to orbit the Earth, and there it's the orbit, okay, and it's about counterclockwise. And now the thing is, if you've heard people talk about the near side of the Moon, that actually is the side of the Moon that we always see. There's a side of the Moon, we only see one side of the Moon, and it may or may not be the lit up side by the sun. Kind of us seeing one side of the Moon is independent of what phase it's in, for sure. So here's the deal. If we call this position 1, 2, this is the Moon, orbiting the Earth. 4 positions, those are quarter positions. What this gal has done on purpose is, do you see where as she goes from position 1 to position 2 in her orbit about the Earth, she is twisting 1/4 turn. So to go 1/4, she twists 1/4. Similarly, between position 2 and position 3, she goes 1/4 and she twists 1/4. Position 3 to position 4, she moves 1/4 orbit and she twists 1/4 on her axis. Okay, what we have, or what the specific thing is, what she's doing. The Moon has synchronous rotation. And we're going to see that other satellites, as they orbit their planets, also have synchronous rotation. And so what that means is the orbit, or the revolution, equals rotation, or spin. When I say they're equal, I say they take the same number of days. So only if this is the case do we see the same, and I'll kind of point out, this is the near side, this is the near side, this is the near side, and the front of her is the near side. We only see one side of her, okay, because she is spinning at the same rate that she is orbiting the Earth. So, I hope you can convince yourself. What's the deal? This actually is a photograph of both sides of the moon. If I were to ask you which side of the moon do you think you see when you look up at the moon in our sky, I am betting that you would say our moon looks like this. These kind of dark regions make out features like we call the man in the moon, the rabbit in the moon, the lady in the moon. Okay, these actually are what we call mare. The term right here, mare. Okay, there's a nice crater called Tycho. But then this side is the side of the moon. This is like that gal's backside. The side of the moon that we don't see because the moon will rotate it away as it's orbiting the Earth. Okay, this is the far side of the moon. So it just really, they look different. This far side looks like it's beaten up, and it has taken more of a beating than the near side.